If I ask you to convert a non-terminating and repeating decimal number into a perfect fraction, how would you do it? At the end of this video, you will be able to answer this question. But before we start, let's see an important information. We need to know how to shift decimal to the right using power of 10. Every time we multiply a decimal number by power of 10, then decimal will shift right by that many places. For example, if we have 0.35 and we multiply it with 10 to the power 1, which is same as 10, then our decimal will shift one place to the right, giving us 3.5. Similarly, if we multiply 0.35 with 10 to the power 2, then our decimal will shift two places to the right, giving us 35. Similarly, if we want to shift decimal to the left using power of 10, we can do that by dividing with power of 10. Dividing with power of 10, shift decimal left by that many places. For example, if we had 20.457 and we divide it with 10 to the power 1, then our decimal will shift one place to the left, giving us 2.0457. Similarly, if we have 20.457 and we divide it with 10 to the power 2, our decimal will shift two places to the left, giving us 0.20457. With this information, let's move to the main topic of this video. Here is our first challenge. Convert 0.333, where 3 is repeating, into a perfect fraction. Look at this question. The biggest hurdle is the repeating 3's. It goes on forever. We need a way to get rid of it. So the biggest question is, how can we get rid of it? Think about it. If we have two equations with the same repeating part, if we subtract them, the repeating part will cancel out, giving us perfect numbers. So let's figure out two equations. Let's start by declaring our number as a variable x. Look at this. There is a repeating 3 right after decimal point. So we label it our equation 1. Here, just one digit is repeating after decimal point. So we multiply both sides by 10 to shift decimal one place to the right. So we have 10x is equals to 3.333 repeating. Look at this equation. We have repeating 3 right after a decimal point. So we label this equation second. So we are looking for two equations with same repeating part. Here we have two equations. Let's subtract them. Subtract equation 1 from equation 2. 10x minus x is 9x, and here right side we are completely get rid of repeating 3's, leaving us with a perfect 3. So let's solve for x. We divide both sides by 9. So we have x is equals to 3 over 9. We can further simplify it by cancelling out common terms, giving us 1 over 3. So let's keep this result x is equals to 3 over 9 for later observation. Let's move to our next question. In this question, we have to convert a 0.363636 with repeating 36 into a perfect fraction. Let's assign this number a variable x. You can see here there is repeating 36 right after decimal point. So we label this as equation 1. Since here two digits are repeating, so we multiply by 100 both sides. So we have 100x is equals to multiply by 100 shifts decimal two places to the right. So we have 36.363636, and as 36 is repeating just right after decimal place, we label it equation 2. So let's get rid of repeating 36. For that, we subtract equation 1 from equation 2. So we have 100x is equals to 36.363636, and our first equation is x is equals to 0.363636. As we subtract them, we got 99. X is equals to 36. Let's solve for x. So here we have our next question. Convert 0.120120 into a perfect fraction. Here you can see the 3-digit 123 is repeating, so we can put a bar over 120. Let's assign it a variable x. Since you can see here that digits 1 to 0 is repeating just right after decimal digit, so we can label this equation 1. Since here 3 digits are repeating, let's multiply by 10 to the power 3 both sides. So we have 1000x is equals to our decimal point here, shift 3 digits to the right. So we have 120.120 repeating. Since here the digit 120 repeats right after decimal digit, so we label it equation 2. To get rid of repeating part, we subtract equation 1 from equation 2. Let's do it. We have 1000x is equals to 120.120 repeating, and our first equation is x is equals to 0.120 repeating. So as we subtract, we have 999x is equals to 120. Let's solve for x. X is equals to 120 over 999. We divide both sides with 999. We can simplify it by cancelling out common terms. But for further study, let's keep this result. X is equals to 120 over 999. As we solved our 3 questions, we have kept these 3 results. Look at these results. Here we have 0.3 where 3 is repeating. Look at its fractional form. Here we have the number without a decimal digit, and in denominator we have as many 9 as repeating digit. Same here in question 2. We write these numbers without decimal, and in our denominator we write as many 9 as many repeating digits. Here in our third question, we write 120 without decimal, and we write in denominator as many 9s as repeating digits. Okay, so if we have a question 0.576 with repeating 576, we simply write 576 in numerator, and we write as many 9s as repeating digit in our denominator. Let's move to some more complicated numbers. This is our next question. We have 0.0333 with repeating 3. It can also be written as 0.03 and a horizontal bar above repeating digit 3. Let's label it the number x. Notice, in this question, the repeating digit not start right after decimal place. We have a 0 which is non-repeating. Remember, our goal is to find 2 equations with same repeating part right after decimal digit. So let's label this equation 1. Now multiply both sides by 10. So 10x is equals to 0.333 repeating. So you can notice here we have repeating 3 right after decimal place. So label this equation 2. But we need 2 equations with same repeating part right after decimal. We have just 1 equation. Notice in our first equation there is no repeating 3's right after decimal digit. So again we multiply equation 2 by 10. Left side becomes 100x and right side becomes 3.333. So we have 2 equations, equation 2 and 3, that has same repeating 3 right after decimal digit. So let's subtract equation 2 from equation 3. So our left side becomes 90x plus to just 3. The repeating 3's were cancelled out. Now let's solve for x. X is equals to 3 over 90. We can further simplify it by cancelling out common factors. So we have x is equals to 1 over 30. This is our result. Let's do it more quickly. So we solved 0.0333 with repeating 3 equals 3 over 90. From this result you can clearly see we cannot write this directly as we have seen the pattern, repeating number without decimal and as many 9s as the repeating number in the denominator. This result is not equals to this result. So how can we do it more quickly? As we have discussed earlier, if we have a decimal digit and we multiply it by 10, our decimal point will shift 1 point to the right. So here we have 0.3 repeating. Let's divide both sides by 10. So we have 1 over 10 multiplied by 0.3 repeating in our right side. So as we have seen the pattern for those numbers who start repeating right after decimal digit can be written as the number without decimal and as many nines as repeating digit. So here 0.3 we write 3 without decimal digit and as many nines in denominator as many repeating number. Multiply this, so 3 over 90. Let's move to our next question. Here we have 0.002222 where 2 is repeating. Let's label this equation 1. As we want two equations with repeating 2's right after decimal digit, so here we multiply by 100 both sides. So we have 100x is equals to 0.2222. So label this equation 2. We need another equation with repeating 2's. So we multiply by 10 in our second equation. So we have 1000x is equals to 2.2222 which is equals to 2.2 repeating. This is our third equation. Now let's subtract equation 2 from equation 3. So our left side becomes 900x and our right side becomes 2. Now let's solve for x. Our x is equals to 2 over 900. We can simplify it further. So we have 1 over 450. Let's see how can we solve it more quickly. So as we have discussed earlier, if we multiply this number with 100, our decimal will shift 2 places to the right, giving us 0.2 recurring. Now let's divide both sides by 100. So we have 0.002 repeating is equals to 1 over 100 multiplied by 0.2 repeating. As we have seen the pattern, we write the number without decimal and we write as many nines in denominator as repeating number. So we have 0.2 repeating is equals to 2 over 9. Let's multiply this. So this is our answer. This is our final question. We have 2.11666 where 6 is repeating. We can write it as 2.116 and horizontal bar above 6. Let's name this x. Since our repeating digit is 2 digits after decimal digit, so we multiply both side by 100. So we have 100x is equals to 211.6 repeating. Now we have our first equation with repeating part right after decimal digit. Let's find out another equation. So multiply by 10 in our second equation. So we have 1000x is equals to 2116.6 repeating. So this is our equation 3. Now subtract equation 2 from equation 3. So we have 900x in the left and in the right side we get rid of repeating part and we left off with 1905. Solve for x. X is equals to 1905 over 900. This is our answer. We can also cancel out common terms, but this is also okay. Let's see how can we solve it quickly. So we have 2.116 repeating. We can write it as 2 plus 0.116 repeating. Let's first convert 0.116 repeating into fraction. So we have 0.116. We can multiply it by 100 and shift decimal digit right 2 places. So we have 11.6 repeating. Now let's divide both sides by 100. So 0.116 repeating will be 1 over 100 multiplied by 11.6 repeating. Now we can write 11.6 repeating as 11 plus 0.6 repeating. As we have looked at the pattern, we can write 0.6 repeating as 6 over 9. We can add 11 and 6 over 9, which is 105 over 9. Now multiply it by 1 over 100, which is 105 over 900. So we have 2.116 where 6 is repeating, 2 plus 0.116. So we replace 0.116 where 6 repeating with 105 over 900. Adding them will gives us 1905 over 900. This is homework question for you. Here we have two decimal numbers. You have to convert it into perfect fraction. Write your answer in the comment section and also write your queries.